5 steps to better Wi-Fi in your house, improving your wireless connection. Especially with so much more happening in and from the home, our internet connection is becoming used more and more, and the weak points are becoming more and more annoying. Sometimes the Wi-Fi signal, your Wi-Fi speed, is in fact one of those weak points. 5 steps to better Wi-Fi in your house, improving your wireless connection. Wi-Fi has only become more important as more devices and online activities become essential at home. I'll review some of the things to investigate as you search for better Wi-Fi. I'm Leo Notenboom. This is askleo.com. Thank you to the patrons of Ask Leo for making it all possible. askleo.com/patron for more information about how you can help and what you get in return. Question. My Wi-Fi supports 802.11 ABGN. I want to know which is actually being used, and if it is not optimal, what can I do to improve it? The ABGN are all different variations on the 802.11 Wi-Fi protocol. Which gets used is mostly out of your control. On the other hand, there are definitely several steps that can improve your Wi-Fi performance at home. Summary. Wi-Fi is, at its core, radio. As a result, it's susceptible to various radio-related problems. Among those are interference, placement, frequency and channel selection, antennas. Additional solutions include potentially adding hardware such as radio repeaters, additional access points, and more. As a last resort, wired connections are almost always faster than Wi-Fi. Some definitions. The terms router, access point, and hotspot are often used interchangeably, even though technically they mean different things. For the purposes of this discussion, router is the device having a single connection to your ISP. All your computers and internet-connected devices get internet service through the router. Wireless access point, or WAP, is a device with hardware that implements and supports the Wi-Fi wireless networking protocol. You may have a single physical box that includes both, or they can be separate devices. While you'll generally have only one router, you can have multiple wireless access points. 802.11 protocols. As I mentioned, 802.11 ABGN and a bunch of other letter combinations are nothing more than different protocols under the 802.11 umbrella. Some are quite different from one another, and they have different characteristics. Some are faster but more susceptible to interference. Others are more robust but slower. Some are older and supported in almost every Wi-Fi device you might have, while new variations are being developed and released over time and may not be supported across the board. You can see which protocol is currently in use in Windows by running a command prompt or PowerShell and entering netsh space WLAN space show space interfaces. This will display an assortment of information about your connection. In the example above, you can see, next to radio type, that my wireless interface is connected using the 802.11n protocol. This displays whatever protocol was negotiated when your Wi-Fi was connected. And it is a negotiation. 802.11 protocol selection. This audio may bring back memories for some. That's the sound of a modem connecting to the internet in the days before broadband. What you're hearing is the local modem and the remote modem negotiating what audio protocol to use. There were several to choose from, and the choice was mostly based on compatibility. Both ends had to support the protocol, and the quality of the sound. The resulting protocol could range in supported speed from 300 baud, bits per second, to a then blistering 56,000 BPS. The same concept happens when you connect using Wi-Fi. Your Wi-Fi adapter and the WAP negotiate which protocol to use based on what they both support and the quality of the radio signal they're experiencing at that moment. I'm not aware of a way to manually select which of the various 802.11 variants will be selected. The negotiation should select the best protocol for the environment at the time. It's possible that the protocol will be renegotiated from time to time as conditions change, but that's generally transparent. Better Wi-Fi in your control. With all that out of your control, what remains in your control is to give your Wi-Fi an environment that allows it to make the best possible connection. Much of it boils down to removing or reducing things that interfere with the radio signal, as well as giving the radios at either end the strongest signal and best reception possible. 1. Placement. The further apart your WAP and computer are, the weaker the Wi-Fi signal between the two. The ideal placement then reduces that distance as much as possible. In the home, this usually means figuring out a central location between all those devices and placing the WAP there. It might involve moving your router there if it includes the WAP hardware. Placing a WAP in a central location is the first best thing to do if you can. It maximizes the strength of the radio signals being received by all the devices. 2. Placement redux. There's an issue with respect to placement that can invalidate the put it in the middle rule of thumb, and that's interference. Sometimes moving a WAP to a location slightly further away can avoid interference and result in better Wi-Fi overall. For example, if your WAP sits next to a cordless landline phone, then a phone call can interfere with the Wi-Fi performance. Microwave ovens are also notorious interference generators. In fact, almost any electronic device can interfere with wireless networking signals. Moving your WAP, your computer, or if possible the source of the interference can help. Interestingly, it doesn't have to be an active electronic device interfering with a radio signal. Large metal objects, even aluminum building materials, can cause problems. Since it's not always possible to point a finger at an interference source, one of the best things you can do is experiment with different locations to see what works well for you. 3. Frequencies and channels. Wi-Fi operates on two separate frequencies, 2.4 GHz and 5 GHz. Some protocols and WAP make these transparent, using whatever works best, while others force you to make a choice. For example, the router provided by my ISP shows two separate Wi-Fi access points, one at 2.4 GHz and one at 5 GHz. 5 GHz is generally faster, but it is more sensitive to obstructions and distance. If you have the option, try the other one from whichever connection you normally use and see how it performs. Within a given frequency, Wi-Fi protocols operate on assigned channels. Depending on your WAP and your wireless adapter, you may be able to select a different connection or channel with a stronger signal or one less prone to interference. The best way to determine what's available is to use a Wi-Fi Analyzer app. There are a couple in the Microsoft Store for Windows 10, and you'll find mobile equivalents in the Google Play or Apple stores. These utilities show available networks and their relative signal strengths, as well as what channels are being used or possibly overused. Changing networks is as simple as selecting a different network in Windows. Changing channels, on the other hand, depends on the specific WAP and wireless interface you're using. Check the documentation for each. Better antennas. The better the antenna, the better the radio's ability to both listen, receive, and send, transmit. As it turns out, this is true for almost all types of radio communications, not just Wi-Fi. Many WAPs have detachable/replaceable antennas. One of the things to look for then might be larger replacement antennas for that device. Often replacement antennas are simply twice as long, which may noticeably improve signal quality, resulting in better Wi-Fi. If you go this route, make sure to look for antennas designed to work with your specific router. Laptops and mobile devices, on the other hand, often have built-in, inaccessible antennas. Desktop computers, if they include Wi-Fi, may have a connector to which you can attach an external antenna. In cases where the antenna is inaccessible, there's little to be done other than perhaps using an external USB Wi-Fi adapter instead, ideally one to which you can attach a larger external antenna. 5. Add hardware. As I mentioned, you can have more than one WAP. and it's often the right solution to extend or increase the range of your wireless network. You can add a WAP wired to your router. This generally gets you the best results overall. You can add a wireless repeater. This requires no additional wires, but since it uses two wireless connections, back to your WAP and forward to your computer, it can be a little more sensitive to radio signal issues. A third option is similar to adding a WAP, but instead adds what's called a mesh network. These are two or more WAPs that are themselves connected on a separate non-Wi-Fi wireless connection to provide Wi-Fi coverage throughout your house. Better Wi-Fi. As you can see, there are several things to consider when attempting to improve the Wi-Fi connectivity in your home. Given how much we've come to rely on it, doing so might well be a worthwhile investment. One last thought though. Wired connections are almost always faster and more reliable. A wired Ethernet connection to your desktop machine or other devices that support an Ethernet connection is always worth considering. In fact, I'll even say it's the first thing worth considering. Sometimes the best Wi-Fi is no Wi-Fi at all. If you found this article helpful, hopefully your Wi-Fi is faster, or you'll at least understand what happens next. Then I'm sure you'll love Confident Computing. My weekly email newsletter is full of articles that help you solve problems, stay safe, and increase your confidence with technology. Subscribe now, and I'll see you there soon. For links related to this article or to leave a comment, visit askleo.com/123219. I'm Leo Notenboom. This is askleo.com. Thanks for watching.